This topic is about identifying special properties of the trigonometric graphs, including their symmetries. We need to be able to find all the angles in a given range that give the same value of a trigonometric ratio. We will begin with the basic definitions. So if we have a right angled triangle and we have a labeled angle, let's call it theta, then opposite this labeled angle theta is always opposite. So let's call that O. Okay, opposite the right angled triangle is always hypotenuse because it's the longest length in a triangle. And next to the labeled angle is adjacent. Okay, then according to SOHCAHTOA, sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. Now we'll use this fact to explain something about the unit circle. So here I have a unit circle. So unit circle means it's a circle with radius 1. Okay, now if I label this angle as again x, then opposite this angle is O, and next to this angle is A. Then sine theta is equal to opposite over hypotenuse, which means it's opposite over 1 because the hypotenuse is 1 because it's a unit circle, which means sine theta is equal to opposite. So opposite is sine theta. So that means the y-axis is equal to sine theta. If I do the same thing as cos theta, which is adjacent over hypotenuse, which is adjacent over 1, because it's a unit circle, so it has a radius of 1, then it's equal to adjacent, which means cos theta is equal to adjacent. So this x value here is cos theta. So x is equal to cos theta. So as we change this angle, this point is just cos theta sine theta, just for the unit circle, yeah? So a circle with a radius 1. So let's explore this on a graphing software so we can see what happens with the sine and cosine graph. Also, the tangent of a graph is just how steep that line is. So tangent refers to the steepness of this line. So let's see all these three graphs in a graphing software. Now, if we're looking at the sine graph, remember the sine graph is represented by the y-axis. So when the angle is 0 degrees, the y value is 0. So that means the sine graph will start off with 0. Now, as I increase the angle, notice how the y value is increasing from 0 as I make the angle more and more bigger. So you can see the sine graph taking shape on the left-hand side. Now, when the angle is 90 degrees, it will reach a value of 1. So sine of 90 is 1. Now, when the angle becomes obtuse, the y value decreases. So the graph goes down all the way until the angle is 180 degrees, where it equates to 0 again. I make the angle bigger than 180, which is reflex. You can see the y value is negative. And it's getting more and more negative until it gets to 270 degrees, where it's equal to -1. After 270 degrees, we can see the y value is getting less and less negative until it gets back to 0 at 360 degrees. So that's the sine graph. If I go on to do the cosine graph, remember that's represented by the x-axis. So x is value is 1, so that means the cosine graph starts off with 1. Now, as you can see, the x is decreasing, so it's going down as it moves to the left of the x-axis, all the way until at 90 degrees, x is 0. Okay, after 90 degrees, you can see it's getting negative. So the x value is negative. all the way up to -1 at x when the angle is 180 degrees. When the angle is bigger than 180 degrees, you can see it's becoming less and less negative. So it's going back closer and closer to 0. And it hits 0 when the angle is 270 degrees. After 270 degrees, you can see x is positive again. And then all the way up to x is equal to 1 when the angle reaches 360 degrees. So that is the cosine graph in red. Now the tangent graph, remember, is measured by how steep this angle is. So the steepness of the line is just 0. So the tan graph starts off from 0. As I open up the angle to an acute angle, you can see it's a positive gradient. So that's why, and it's getting more and more steep. That's why the tan graphs get more and more steep until at the angle 90 degrees, it's a vertical line, which means it's undefined. So we get asymptote. So it's undefined, which means when it's 90 degrees, we can't say what the gradient is. So there's normally no value at x equals 90. Okay, as it goes more than 90, you see it's a negative gradient. It's very steep. So this part of the graph will be very steep. As you increase the angle, it's going to get less and less steep all the way until it reaches 180 degrees when the gradient is 0. When the angle is bigger than 180 degrees, you can see the gradient is positive, but it's a slight positive. And obviously, as we go along, it's getting more and more steep. So it's going to get, the line will get more and more steep. All the way until you reach an angle of 270 degrees, where again, it's vertical. So it's undefined at 270 degrees, which means there's going to be an asymptote at there as well. When it's greater than 270 degrees, again, it's negative. And it's going to be very negative because obviously it's very steep. As you increase the angle and get closer and closer to 360 degrees, where the gradient will be 0. So the green one is the tangent graph. So these are all the trig graphs for each trig ratio. So if we were to write this out formally, so features of a sine graph. So sine graph, remember, starts off at 0. If I call this 1, and I call this -1. Reaches 1 at 90, reaches 0 at 180, -1 at 270 and 360. It's at 0, so it looks like so, the sine graph. And because it's repeated over and over again, because you can go around the circle more than once in the opposite direction, it looks like so. So this is the sine graph. So y is equal to sine x. Now, if I wanted to go through the features of this graph, because it repeats every 360 degrees, we say it has a period of 360 degrees. The range, which is the y value it takes, so range is from -1 to 1. So the lowest point is at -1, the highest point is at 1. And the roots are at x equals 0, 0 degrees, 180 degrees, 360 degrees, -180 degrees, blah, blah, blah. So you can see starting from 0 is every 180. So x is equal to 180n, where n is the element of integers. So 180 times 0, 180 times 1, 180 times 2, and so on. Okay, so those are the features that you need to remember for a sine graph. Similarly, for a cosine graph, if I were to do a cosine graph so you can see both, cosine graph has a maximum of 1 and -1 as well. It starts off at 1, then it goes to 0, then -1, then 0, then 1. So it's very similar to a sine graph, but it's shifted slightly. So if I were to sketch it out, let's try that again. Might be good if I make it bigger. And again, because it repeats every 360, okay. And features are somewhat similar to a sine graph. So it does have a period of 360 degrees. Range is from -1 to 1. This is y is equal to cosine x. And the roots are at x equals 90 degrees. That's the first one, and then you add and subtract 180 degrees to get the next one. So 270 degrees minus 90 degrees minus 270 degrees. So I had to simplify it and write it down. If I write 90, so if I start off with 90, which is the first one, plus or minus 180 lots of n. N is the element of integers. That means 90 plus 180 times 0, 90 plus 180 times 2, 90 plus 180 times -1. All of those will give you roots. Okay, and the main thing is these two graphs, sine and cosine graphs, sine x and cos x, are translations. Of one another. So what I mean is if I shift it, I can get the other one. So if I shift the sine graph to the left by 90 degrees, then I can get the cosine graph. If I shift the cosine graph 90 degrees to the right, then I can get the sine graph. So they are translations of one another. And they do have a relationship, the sine graph and cosine graph. Okay, the tan graph is slightly different. So let's look at the tan graph. Graph starts up at 0. Then it has an asymptote at 90 because remember it's vertical at 90 degrees, so it's undefined. 180, there's a root. Again at 270, there's an asymptote. Every 180 degrees, there's an asymptote. So it is. Okay, so it gets steeper and steeper and steeper, closer and closer to the asymptote, and then stops. There's steep going through 180, getting closer and closer to 270, but never reaching it, so on. And you can see it's the same pattern repeated every 180 degrees. So this one, tan graph, is slightly different. So period of 180 degrees for this one. Okay, so tan graph has asymptotes at x equals 90 degrees, 270 degrees, minus 90 degrees, minus 270 degrees. So x is equal to, again, similarly, if you start off with 90 and keep adding 180 lots of n, then you get all of them. And the roots are at x equals 0, 180, 180, not 270. Don't write that. It's every 180 because it repeats itself every 180. So roots are at 180 lots of n. N is the element of integer. Okay, so we need to find angles that give the same value using these graphs. So I've got a sine theta graph going from -360 to 360. So it says find all the angles that give the same value as sine 10. So sine 10, so 10 would be somewhere here. So if I were to draw it out, 10 is somewhere here. It's going to be roughly drawn out. So sine 10 is this value here. Now if I draw a line going across like this, all the way, then all these points, all these theta values give the same value as sine 10. so on. Now we're looking for the theta values between minus 360 and 360. Now because this is 10, this part will also be 10. So sine 10 will be the same thing as sine 180 take away 10. So 180 take away 10 is 170. So it's the same thing as sine of 170 degrees. So that's the first one. So that one I've got now, so that's 170 degrees because of the symmetries of the sine graph. Now this one, I know it's going to be more than 360, so we won't work that one out. But if we were to work that one out, it would just be, because this is 10, that will also be 10, which is 370. But we don't need that one, so don't worry about that one. Okay, so what we need to find out is obviously this one next. So this one, what is that one? Okay, so again, if I draw this, because of the symmetries of the graph, that must also be 10. 10. Because it's on the left-hand side of minus 180, that must be minus 180 take away 10. So it's the same thing as sine of minus 190. Okay, so that one's now done. So we just worked out that one. Okay, now I need to work out this one. Okay, again, because of the symmetries of the graph, that's 10. So it's on the right-hand side of minus 360. So it's going to be minus 360 plus 10, which is sine of minus 350. Okay, so that one would be for sine 10. So let's rub this out and do the next one, see how it works out for the next one. Okay, so the next example says sine 190. Okay, 190 is somewhere here. Let me just draw with red. So 190 is somewhere here. Okay, again, if I want to, sine of 190 is these values here. Okay, 180, the difference between that and that, because 180 is a key point on this graph, is 10. Okay, it's 10. So sine 180, and we've got this one. So these are the other ones that we need to look for. This one, and that one. Okay, so first one is going to be, because this is 360, that must be 10. So 360 take away 10 will give us the first one, which is sine of 350. You can put brackets around it if it makes you more comfortable. Okay, next one is, so that one is done. So this is sine 350. Okay, this one here must be 10. So because it's 10 away from the y-axis, that must be sine of minus 10. That's sine of minus 10. This one here must be 10 minus 180, add 10, because it's before minus 180. So that must be minus 180 plus 10, which is sine of minus 170. Okay, those are all within the range of minus 360 to 360. Next one is sine of minus 280. So minus 270 is here. Sorry, minus 270 is here. Minus 280 would be somewhere here. Okay, so we're looking at all these values. So this is minus 280. Remember, if we look at the peak there, that's 10 away from the peak. So minus 280. So the first one, so if this is the one we've got, first I want to work out that one. So if this is 10 away from 270, that is 10 to the right of negative 270. So that must be the same thing as sine of minus 270 plus 10, which is minus 260. Okay, the next one I need to find is this one. Again, and that one. These are 10 away from the peak because of the symmetries of the graph. 10 away from 90 in either direction is sine of 80 degrees and sine of 100 degrees. So that would be the answers for each one. Okay, cosine graph. First, cosine of 10, find all the ones that have the same value as cosine 10 in between minus 360 and 360. So cosine 10 will be somewhere here. So this is 10. Okay, which is 10 away from the peak. Sorry, my drawing is rubbish. Okay, 10 away from the peak. 10 away from the peak. So 10 away from there. Okay. For this one, it will be 10 away from the peak again. And 10 away from the peak there. Okay, so the first one is cos 10. Now, because the cosine graph is symmetrical along the y-axis, it's the same thing as cosine of minus 10. Okay, so we've got this one we had already, this one we've got now. Okay, we need to find this one. This one, which is 360 minus 10, which is cosine of 350. Now, it's really easy because it's symmetrical. Cosine 350 here means that one must be cosine minus 350. So you don't have to even work it out. You can just see if cos of x satisfies the answer, and then cos of minus x would also satisfy the solution. Okay, but if you didn't want to do it that way, you can still work it out the traditional way, which is at minus 360, you've got a peak. It's 10 more than minus 360, which is cos of negative 350. So it does work out. Okay, let's try the next example. If you look at the next example, we're trying to find cos of 190. So 190 is somewhere here. So this is 190, which is 10 away from the peak. Okay, so again, if we were to draw this out like this, then we've already got this one. We need this one, and this one. Okay, if this is 10 away there, this is 10 away this way, which means it must be equal to 10 less than 180, which is cos of 170. Because of the symmetries of the graph, if cos 190 gives a value, then cos of minus 190 will give the same value. And cos of minus 170 will also give the same value. Just to make sure that works out, we know this is the peak happens at the peak, the bottom happens at the least value is at minus 180. It's 10 away in either direction, both these ones, from 180. So it is minus 190 and cos of minus 170. Okay, the last one is cos of negative 280. So negative 280, negative 270 is here, negative 280 is somewhere here. So negative 280, go up, and when it hits the curve, we're looking for all these values where it hits the cosine graph. So if we're looking for the right ones, we've already got this one. So that one's already done. We need this one, and this one. Okay, if you look at this point of the graph, that is minus 270 where it goes through. So this is 10 away there, 10 away there, 10 away. Okay, so if I want to find this point, this must be 10 away from negative 90. It's 10 more than negative 90, which means it's cosine of negative 80. And because of the symmetries of the graph, it's symmetrical around the y-axis. So if this is minus 180, that would be positive 180. And that one must be positive 280. But let's check that that's true. So if this is 10 away from 90, it's 10 to the left of 90. So it's 90 take away 10, which is 80. This one is 10 more than 270, which is cos of 280. That's correct. Okay, let's do a similar thing with tan graph. Tan is slightly more easier than cosine and sine graph because it repeats itself every 180. So tan 10 is somewhere here, let's say. Tan 10. Tan 10. Now, because it repeats itself every 180 degrees, all I need to do is add 180 or subtract 180 to get the next one. So tan 10 is the same thing as tan 10 plus 180, which is equal to tan of 190 degrees. Tan of 10 is also the same thing as 10 take away 180, which is equal to tan of minus 170. And so I've just worked out, I already had this one. I've worked out this one and I've worked out this one. The last one I need to work out is this one, right then here. If I keep subtracting 180, I get the next one. So minus 170 minus 180 is tan of minus 350. So that would be the answer. So it's very easy. You don't even have to, with tan graph, I sketch it out, but it's very easy to work out. All you have to do is keep adding or subtracting 180. So 151 plus 180. 150 plus 180 is equal to 330. So tan of 330 is the same thing. Tan 150 take away 30 is tan of negative 30. And if I subtract 180 more, I get tan of negative 210. Tan of negative 280, if I keep adding 180, I get the next one. So it'll be tan of negative 100. If I keep adding 180 again, it'll be tan of 80. And if I add 180 more, I get tan of 260. Now, this skill is useful when you're trying to solve trig equations, so make sure you're able to use the graphs to find angles that give the same value, because you're normally given a range for which you need to solve for, which means there's most likely going to be more than one answer.